Hello everyone. Today we are going to discuss one-step binomial option pricing model in which we will be valuing an European call option. Here I have considered a stock whose current stock market price is 100 rupees, and it is expected that in after 2 months its price will either increase by 10% or will decrease by 10%. We can draw it on a binomial branch as such that the current stock market price is 100, and it is expected that after 2 months it will be either increasing by 10% or decreasing by 10%. So an increase of 10% means 110 rupees and a decrease of 10% means 90 rupees. So the question states that the current stock market price is 100 rupees and it is expected that in future it will either increase by 10% or decrease by 10%. So 110 and 90. And here we have considered an European call option whose maturity period is 2 months and the strike price is given 100 rupees. And we have to determine the value of the option, that is F, and here we are having some additional information as well, that is risk free rate of interest is equal to 10%, and time period as already mentioned it is 2 months, so we have converted it to years, so it is 1/6 years. Further, first of all we are supposed to determine the probability of upward movement and downward movement. So as in the previous session we have discussed, P is termed as probability of upward movement and 1 minus P is termed as probability of downward movement, and the value of the option is written over here, that is F, and the value of upward movement of the option is termed as Fu since it is upward, so Fu, and the downward movement it is termed as Fd since it is downward, so Fd. And here we are talking about a call option, and as we know a call option is exercised when the spot market price on the date of maturity is greater than K. It means that if on the date of maturity the spot market price, that is the maturity price on the date of maturity, is less than 100 rupees, the option will remain unexercised, and if it is exercised the payoff can be determined by St minus K. For example, here St is 110 and the strike price is K, and it is a call option, so if it is exercised on the date of maturity, the long position holder will be having a payoff of 10 rupees. Similarly, when it is 90 rupees, that is spot market price on the date of maturity is 90 rupees and K is 100 rupees, so St minus K, 90 minus 100, we will get minus 10. It means the long position holder will not be exercising the option when the price is 90, that because it is less than K. Therefore, the payoff to the long position holder will be 0. Now we have to determine the value of P, but before that we have to determine the value of U, and as we know that we can call 110 as S0U because it is upward movement, so we can write it as S0U is equal to 110 and S0 as it is given 100 rupees. So from this we can determine the value of U. U is equal to 110 divided by 100. So U comes out to be 1.1, and similarly we can determine the value of D, that is 90 divided by 100. So it comes out to be 0.9. Now if you will recall the formula of P, the P can be calculated using the following formula, that is exponential raised to the power RT minus D upon U minus D, where R is given 10%, T is 1/6 years and D is 0.9, U is 1.1. Just plug in these values in the equation, we will get exponential raised to the power 0.1 divided by 6 minus 0.9 divided by 1.1 minus 0.9, and on simplification we will get it approximately 1.0168 minus 0.9 divided by 1.1 minus 0.9. On solving this one we will get 0.5840. So we have got the value of P, that is probability of upward movement is 5.840. Now we can calculate the value of 1 minus P, that is 1 minus 0.5840. On subtracting 5840 from 1, we will get 0.4160. So the probability of downward movement is 4160 and the probability of upward movement is 0.5840. Now we have to calculate the value of FU and FD. We have already calculated. FU is 10 rupees and FD is 0. So the value of the option, European call option, can be calculated using the following formula, that is F. Now as we can see, P is onto the upward branch, so P multiplied by FU. Like this way we can remember the formula, that is P multiplied by FU plus another branch is over here, that is 1 minus P into FD. So plus 1 minus P into FD. Now 110 and 90 is the future value and we have to calculate the present value at the time 0. So we have to discount this one, and these values, that is FU and FD, is the future value. So we have to discount it and convert it into the present value. So what we have to do, we have to multiply it by exponential raised to the power minus RT. Now we are having all the values over here. We can just plug in and solve for the value of the option. So it comes out to be 0.5840 multiplied by 10 plus 0.416 multiplied by 0, then exponential raised to the power minus 0.1, that is 10%, multiplied by 1 upon 6. On multiplying this, we will get 5.84 plus 0. Now on solving this one, we will get 0.98347. So what we have to do, we have to multiply 584 by 0.98347. On solving this, we will get 5.7434, approximately this much rupees. So the value of the call option, that is F, is equal to rupees 5.7434. So like this way we can calculate the value of an European call option. Now we will be doing it for European put option. Using the same values, that is S0 is equal to 100 rupees. The probability of upward movement and downward movement, that is the price movement, will be either plus 10% or minus 10%. And 2 months, again the same thing we are considering. And here strike price is also the same, 100 rupees. And the risk free rate is also the same, that is 10%, and time, obviously it is 1 upon 6 years. Here we are going to value an European put option. So remember this thing we are doing for put option. Now in case of put option, we know that the put option gives the holder, that is the long position holder, the right to sell the underlying asset but not the obligation. Therefore the put option holder will be exercising the option only when the strike price is greater than the spot market price on the date of maturity. Hence the payoff for put option holder is, remember, it is K minus ST. That is, whenever the spot market price of the on the date of maturity is less than the strike price, the put option will be exercised. Now again, drawing the binomial tree, the spot market price today is 100 rupees and the probability of upward movement and downward movement is plus 10% minus pardon for my mistake, the upward movement will be either 10% or downward movement will be either that is minus 10%. So the price will be either 110 or 90. Going by the same values, that is 100, 10% increase means 110, 10% decrease means 90, and using the same as we are using the same value, so u is equal to 1.1 and d is equal to 0.9. So similarly, the probability of upward movement p and the probability of downward movement, that is 1 minus p, and this is fu and this is fd. Since upward, so fu, downward, so fd. And it is a case of put option, and put option is exercised only when the spot market price on the date of maturity is less than the strike price, and the payoff of put option is calculated using the formula k minus st. Now on the date of maturity, the spot market price is, let us say, 110 and the strike price is 100. So 110 and 100 is the strike price. So 100 minus 110 comes out to be minus 10, and as I have already mentioned, the put option is exercised when k is greater than st, and here st is greater than k, hence the put option will not be exercised. Therefore the value of fu will be equal to 0, and here the spot market price on the date of maturity is 90 and strike price is k, so that is 100. So 100 minus 90 comes out to be 10 or 0. Maximum out of 0 and 10 is 10. So the value of fd is 10, and we have to calculate the value of p, that is exponential raised to the power rt minus d upon u minus d, where r is 10%, so 0.1, t is 1 upon 6, so divided by 6 minus 0.9 whole divided by 1.1 minus 0.9. On solving this one, as we have done in the previous case, so the same value we will get, that is 5840. From this we can calculate the value of 1 minus p, that is 1 minus 0.5840. On subtracting we will get 0.4160. Now we have to calculate the value of the put option, that is f, and as I have already mentioned, we can write the formula in this way. P is one of the branches, so p multiplied by fu plus another branch 1 minus p into fd plus 1 minus p multiplied by fd. Now these are the future value, we have to discount it and convert it into the present value, so multiplied by exponential raised to the power minus rt. Since it is a single time step, so I am just writing rt. Now in second case, when it is more than one time step, there we need to remember this fact that it would not be rt. For the time being, we will solve this one, that is p into fu plus 1 minus p into fd multiplied by exponential raised to the power minus rt. Now we are having all the values with us, that is p is given calculated as 584, fu is 0, 1 minus p is 0.416 and fd is 10 multiplied by exponential raised to the power minus 0.1 divided by 6, and what we will get, 0 plus 4.16 whole multiplied by exponential raised to the power minus 0.16, we get 0.98347. Now we have to multiply 4.16 into 0.98347. On multiplying 0.98437 with 4.16, we get 4.0912. So this is the value of the put option, that is 4.0912. So the value of put option is calculated as 4.0912. So you can use these two cases for calculating the value of a call option as well as a put option. So in the next video we will be doing for two-step model. Thank you.